Hello and welcome to this video on implicit differentiation. Now I'm going to spare you most of the theory behind why implicit differentiation works and just teach you what you're going to need in order to answer a question on your Call 4 exam paper. Basically, if I have x squared, I can differentiate that to be 2x. If I have y squared, you will differentiate that to be dy dx 2y. And what you will do is you will keep the dy dx next to your function of y, and this is a feature that basically if you have any constant which is like sine y, e to the y, etc., just write a dy dx next to it. That's basically the principle of implicit differentiation, making sure that every time you differentiate y there's a dy dx with it, and you will understand why this is useful in just a minute. Now, first of all, I'm going to show you a couple of questions and just, you can attempt these, and then I will go through how they work. Don't want to write E, probably because it's still stuck in my head as a logs number really, but A, whatever. And then one last one, we're going to go so you can stop your video now and have a go at these, and I'm going to run through them now basically, so please stop the video. Fine, A, quite simply, it's going to be 2x plus 3y squared dy dx. B is going to be minus sine y dy dx. C is going to be 3e to the 3y dy dx plus 3. Do you get the idea? Excellent. Now then, we can continue on to something that's slightly more interesting. So, what we're going to do is we're going to take a slightly different question, and then we are going to go through it using the skills that we've gained in implicit differentiation. Now, I'm going to take the question 3x squared minus 4y squared equals 4x, and we are given the point 2, 1. And it says when the equation is at this point, prove that m equals 1, and that's exactly what we're going to do. Now, using what we have just learned, we're going to do 3x squared differentiated 6x minus 8y dy dx equals 4. Now, normally when you differentiate something you will have to do dy dx equals. Now in this case, as we already have a dy dx, all we need to do is rearrange everything and just get everything over dy dx. So, first of all we'll do, minus 8y, excuse the fact I'm writing things in different order, equals 4 minus 6x, just moving stuff across, dy dx equals 4 minus 6x over minus 8y. Hey, now there we have it in a lovely form that looks like dy dx. I apologise if you can't see it, I haven't moved the paper. Now we can put in our point 2, 1, and that gives us 4 minus 6 lots of 2 over minus 8 lots of 1 equals minus 8 over minus 8 equals 1. Now that proves the gradient, that the gradient is 1. Now usually in these types of questions what they will ask you to do is they will give you a equation like that, and they will say, well, do something. Usually differentiate it and see what happens. And then you rearrange your terms of dy dx to make it into a form like that. Substitute values in, and usually when they've got the gradients, when you've got the gradient, they'll say, show the normal at this point, show the tangent at this point, etc. So we're just going to go and show normal and the tangent. So now we know the gradient's 1, our normal gradient is going to be minus 1, so what we're going to have is we're going to have y minus 1 equals minus x minus 2, y minus 1 equals minus x plus 2, y equals minus x plus 3, x plus y equals 3. And then tangent is obviously going to be the same gradient, so it's going to be y minus 1 equals x minus 2, y equals x minus 2, y equals x minus 1. And that's the tangent and the normal at these points. So one brief recap, quite simply, differentiate your terms as normal. If it's a y term, shove a dy dx on the end of it, and then if you're doing anything like finding gradients, make sure you rearrange it so you've got everything on one side and dy dx on the other. Thank you very much for listening. I look forward to seeing you next.